Hi everybody, it's great to see you here at NAB in person, in 3D, right? It's great to be here. My name is Ralph Barkoven, I'm with Triveni Digital. With me is Josh Weiss, he's with ARC Multicasting, and we're going to talk a little bit about datacasting. Just high level what Triveni is doing from a datacasting and ATSC3 perspective. So we're basically the plumber of ATSC 3.0. We take stuff in and push it out. What's really important about ATSC 3.0, because of the advanced technology in there, you can deliver new advanced services which generate new services and revenue for your company. I'm not going to go too much into detail for that because Josh will actually talk much more about the value of ATSC 3.0. Just from a high level perspective, we are doing this on a station level. You have basically the encoders, our products in here doing all the things for data distribution, and then we go into the RF environment. What Josh and his company are actually doing is they're taking this nationwide. And it's really important to actually understand what the task is of ARC Multicasting doing so, because it's more than one station. It's actually very, very complicated. And what Josh with his other partners like HPE or Comark has done is building a whole ecosystem, delivering data on demand to their customer base. And I'm going to skip this one, and I give it back to you because you have more information than I do.
Well, I appreciate that, Ralph. I'm Josh Weiss, co-founder and CEO of ARC Multicasting. And as Ralph was explaining, we are a broadcaster with stations all across the country. We've got some 300 assets across the country, and we are deploying an ATSC 3.0 network. That's the trajectory. Those 300 stations are 39 different states, cover about 100 million people, and our business that we're working towards is a datacasting model. So what do those stations mean when it comes to a low power television station? So each of these stations have never been used for commercial purposes, so they're unencumbered, which essentially means we don't have a current customer that we're trying to please or that we have to continue serving with a specific service for us to move forward. We can actually use the entirety of our bandwidth to support new business models, as in what we're talking about here. So they're unencumbered. On top of that, each one of these stations, we're upgrading to 3.0. Of course, that's going to be a process. Initially, we've got 10 stations that we are just finishing up our deployment on in ATSC 3.0. They're full builds using Triveni's ATSC 3.0 stack. We're using DASDEC for our EAS service. We're using ATEM for our encoder, and we're using HPE for our broadcast core, which is all the automation and our orchestrator. And then we're using Comark at the transmitter level and dielectric at the antenna level. So we're in the process of upgrading all. Right now we've got 10. Datacasting is the primary business. Each one of these stations, you might not understand 3.0 or rather low power television. So when you think about a full power television station and you think about low power television station, oftentimes we think low power must mean small, but it's actually quite the contrary when you're comparing it to our sisters in the other wireless space. So a low power television station, it can cover 70 miles in geographic area from side to side. So this right here is our Dallas station, covers 6.8 million people. So low power in terms of its comparison to a megawatt full power station, but definitely not low power in terms of the actual amount of contour that it covers. We're going to build these out with a single frequency network, and in our model, we're building that single frequency network out early stage towards a gap filler approach, just to fill in the signal contour and make a stronger link budget throughout our footprint. And these are strong in both UHF and VHF for what we have. So that's kind of what we're building out in terms of an actual network footprint. But what does that actually mean? What are we doing? So we view the value and the power of broadcast from the standpoint of a one-to-many architecture. So multicast, one-to-many, we think that there's a much more efficient, effective, and elegant way to get data to end users than the current unicast model, and as a result, that's what we're going to be capitalizing on when it comes to 3.0. So in 3.0, you think about when a gaming update goes out. That game update might be 100 gigabytes in size. And if those game updates are happening 2, 3, 4 times a month, depending on which game decides to do an update, or an Xbox or PlayStation update, well, in the current model, they're all unicast in nature. So if you've got 1 million people in Dallas that all download that 100 gigabyte file, then you've got that 100 gigabytes traveling across the network 1 million times, therefore congesting the overall network pipe. So when we talk to certain ISPs, they'll tell us that when that 100 gigabyte file goes out, their network is congested some 60 to 65%. And so we see the elegant, economic, and efficient way of using ATSC 3.0 to take that same 100 gig file out and use a multicast hybrid broadcast broadband. We're not replacing the internet, we're augmenting what's currently there on the network. We send that same 100 gig file out, and all of a sudden it's going out one time and it's able to be received by all 1 million of those people, or everybody within the market that's got that receive side. So our business model, when we think of what we're doing, don't think of it in terms of traditional linear television. Don't think of it as our use case being advertising only or IP analytics only. Our use case is anybody who wants to get data from one point to many points. We're going to capitalize on that one-to-many architecture that is broadcast. So it's not one customer vertical, it's any vertical of data transmission, any vertical of trying to get data from one to many. The average household consumes about 650 gigabytes every single month. And that's only going to be going up, as we all know. So 650 gigabytes every single month, going up to over 1 terabyte. The existing legacy networks that exist out there, they really can't sustain that type of traffic. And that's why we see the congestion. That's why we see the buffering. That's why we see the constant approach towards more metered internet services. We're affixed to that because we help to augment those networks and increase it. So our verticals, not limited to, but our verticals can include things like OTT, a streaming provider. Imagine, if a Disney or a Netflix or a Hulu could move the data center all the way to the consumer home, you would never have any kind of download issue or buffering issue. It would be living in their home cache, a data center actually in the home. So when you go to request that popular content, instead of you having to pull that content from the local data center somewhere 50, 100 miles away, you're actually pulling it from the data center in your home if it's that most popular content. Same thing goes for ISPs. If we're able to offload the most consumed data from the ISP network, then that 100 gig file or that popular OTT content or that popular firmware update, whatever it might be that's going out over and over again, it doesn't have to congest their network. So you imagine if you think about it in terms of traffic, you've got the George Washington Bridge, you've got 4 or 5 lanes. We're simply adding an extra lane, and we're not charging the network for that lane. We're only charging the toll for the semis that get routed over that lane, which are currently congesting the traffic in those other 5 lanes. So we are an augmentation, a creative augmentation to the existing ISP network, and as a result of what we're able to provide for them, we relieve their congestion and their bandwidth issues. So in those conversations, if all we did was datacast one gaming update, if all we did was the gaming update, they saw incredible value in our service and our offering. So they would be considered, by the way, a BVNO, a broadcast virtual network operator. So anybody that's wanting to become a virtual network operator on our network, they would be a broadcast virtual network operator, a BVNO. We would open up a portal on our service director, on our customer portal to say, okay, you want to be a BVNO, you want this market or that market, you want this type of mod cod, and then we would open it up for them. Distance learning, another opportunity. We've got an announcement we made not too long ago about our partnership with SpectraRep, where we can serve distance learning across the country, wherever we've got stations, of course. And so distance learning is another great opportunity. We saw during COVID a tremendous amount of struggle and strain because people don't have great connectivity. And so with an ATSC 3 broadcast, we can actually provide their their student learning, their materials, their video files, their PDFs, the things that teachers need to get out, we can do that without any internet at all. The student doesn't have to have any internet. So they don't have to go to the local Starbucks to go ahead and get their content. They can get it over broadcast. And beautiful thing about what SpectraUp's doing is the teacher doesn't have to really change anything about how they do it. They simply go into their learning management system, whether that's Google or Canvas, and they simply say, okay, I'm going to give it to Susie, who happens to be getting it by this new means of getting data out. So datacasting using distance learning, or distance learning using datacasting, the other opportunity. Connected car market. You know, the connected car, you imagine firmware updates going out to all the different cars, that becomes expensive on the cellular connection. It is also something where infotainment becomes a real opportunity, because as more and more cars become self-driving, there's going to be more and more people enjoying and consuming OTT type content or other video type content that can be coming over the broadcast stream, one-to-many, more efficient than the existing unicast approach. Not to mention, when we get into the autonomous driving vehicles, you're never going to be leaning on one source of connectivity for that connected car, because safety is an important thing, and making sure the car understands where it's going, what traffic's like, what weather's like, all those things are going to be very important. So broadcasting and ATSC 3.0, great opportunity with the connected car. You've got the smart agriculture side. You know, those all of those IoT applications, we put in smart agriculture, but really anything IoT, it's much more efficient to utilize a broadcast service like ATSC 3.0 than narrowband IoT, because in a unicast environment, that narrowband IoT becomes very, very cumbersome very quickly and very costly. So the opportunity of using ATSC 3.0 is perfect for that. Then you've got the cloud CDN side. And you might think, well, how does cloud CDN play a role in this? This is already the internet, right? So how does cloud CDN play in? Well, think about it like this. The CDN is a content delivery network that's trying to distribute data closer to the end user. We all hear about edge, but who can really define what edge means? Essentially, it means getting the data closer to the end user. That's the edge. In most applications, that edge lives at a tower site, like maybe American Tower's tower site, right? And there's maybe a data center there, or a data center on the edge of the city. Well, that data center on the edge of city is edge for them because it's closer to the end user. Edge for us extends it all the way to the consumer. So if you have a little set-top box, and that set-top box has a 2 terabyte hard drive, and that 2 terabyte hard drive is living in the home at the network level. Maybe you send the device out, they plug in an Ethernet, they plug in the antenna, they plug in the power, and that's all that's needed. It's very simple, very plug and play, and boom, you've got yourself a CDN infrastructure in the home that helps with OTT, helps with ISP, helps with distance learning, helps with the connected car if you're doing your firmware updates over Wi-Fi, and the end user enjoys the data that's in that CDN at the speed of their local area Wi-Fi. So that's a value proposition for CDNs like all of the Amazons, the Googles, the Akamai's, Limelight, Level 3, or like all of these guys would enjoy a more efficient data center at the edge for the CDN. And it provides an opportunity for them to go to their customers and say, well, you've got your data living here. Would you like to also have it living closer to the end user? So these are just some of the many applications. I'm sure you saw some of the announcements in the most recent week or two of other companies doing some interesting use cases for data casting. The way you should view data casting as it relates to 3.0 isn't a what are we doing and what are you doing, but what can we be doing together? Because the more we work together, the more we create a ubiquitous network with the same type of infrastructure that you see in the cellular world with the interoperable roaming, and we create a nationwide enterprise-grade opportunity that can serve any number of verticals across the entire platform, or any number of verticals on each individual market. And so that's something that we're very keen on doing. So you think about it, what is data casting? How does this compare to what's existing out there today? Well, Verizon talks about their data transmission. During COVID, they posted some numbers about what was actually going out. 218,000 terabytes across their network in one day. You take that, you multiply it out by 30 days, you've got 6.5 exabytes across the Verizon network nationwide in 1 month. 6.5 exabytes, that's a lot of data. You got 1,000 megabytes is a gigabyte, 1,000 gigabytes is a terabyte, 1,000 terabytes is a petabyte, 1,000 petabytes is an exabyte. That's a lot of data, right? So you take that and you look at our Dallas station. Let's just use a round number. On our Dallas low power television station, 6 million people, it's actually 6.8, but 6 million people. You take that 6 million people and you say 24 megabits per second, and of course that varies based on the mod cods, which we get help from Triveni to make sure that we can have the proper PLPs, but you've got 24 megabits we're going to use as just a flat number. You take that 24 megabits per second, you multiply it out, it's about 7.5 terabytes per month. Per person. So when you're comparing us to what the cellular world is doing and the existing networks, we're one-to-many, they're unicast, one-to-one. So if you're comparing apples to apples, you have to take that 7.5 terabytes, multiply that out by everybody passed. You take that, multiply it out by the 6 million that we just used there, you're at 45 exabytes in that same month in one market. In one market. So you take that concept and you think about the economy of scale that we have in broadcast and what we can do with a one-to-many architecture. We become the most efficient, the most elegant, and the most effective way to get data from one-to-many from any existing architecture that's out there. And as a result, that gives us the opportunity to be economical and to explore the opportunities in new ways. It just requires us kind of being a little bit innovative and willing to step outside of our comfort zone of what we've historically done. So we're doing this. You can see here, this is just a video of a demo that we've been doing, and this is showing you the Triveni route MMTP encoder, which comes before the Triveni gateway, which you'll see here in a minute, and then goes into the, I think we're going to show the stream scope as well, which is validating and showing us what we're getting on the receive side. All of these things are very complex, and they're things that we are, in order for us to be able to make it work, we have to work through all stations together in what we call the ATSC3 core. So we're taking all of this, packaging it together, and modifying each station individually from one central place, all thanks to Hewlett-Packard Enterprise. So we're taking the HPE orchestrator, the automation, the edge-to-cloud solution we've got there, that's controlling all of the components that you're seeing on the screen at every station level and giving us the opportunity to offer to a customer all of the versatility that we talked about with every one of those verticals of potential customers at any particular size they choose of the pipe in any market at any time for any period of time, or all of it at once across the entire nation. That's a pretty cool opportunity, and the lifting has already been done. So with that, I want to invite you, if you've got more questions, I know that we've gone through a whole lot here. If you've got more questions, you want to understand how it's working, you want to understand how the different components work, or what the different softwares that are involved here, or if you'd like to see a functional demo, I want to invite you to come and speak with Ralph over at the Triveni booth, or you can come and see the functional demo. There's 2 places on the floor where the demo is taking place all week long. Over at the HPE booth, which is that way about 100 yards. I see Ali over here, one of the solutions architects from HPE. It's also taking place at the Comark booth. And so I want to invite you to come to either one of those booths and see a functional demo. And of course, if you've got questions, we're here as well.